So here's a circle. Let me let that screen load. There it is. There's a circle, and like a circle inside a square. Is that
Yes. Yes.
okay? So that's one
And
possibility.
you're trying to figure out the area of the square itself.
Okay, we can do some problems like that. I mean, is this it? I mean, because there's other, there's actually circles inside
Yeah,
everything.
like polygons with that type of stuff going on.
I mean, you can even have them inside of I guess you can have them inside of almost anything. A hexagon's probably the other big one that you might see.
Yeah, it's mostly trying to work on areas of a circle
Okay.
and how those work with other things.
Okay. Well, let's just start with some basic stuff here. What is the area of a circle? Can you tell me that?
I don't know. That's kind of what we're learning, you know.
Okay. So you're not given this formula pi r squared?
No.
Okay. What are you given? Because it's hard to do this without knowing that.
We take the sides and we get the area of the square, and
Okay.
then we have to find out the diameter of the circle,
Okay.
and then we cut that in half, and then we get the radius, and then we square it, I think.
Okay. Yeah. Yeah. All right. All right. All right. So very good. So yeah. So let's back up here. All right. So let's say I give you something like this, which is a square. Okay. And I tell you that it has a side length of, let's go 12 meters. Okay. What is the area of the square?
It would be 25.
You're multiplying the two numbers together, 12 times 12.
Oh, 12 times 12.
Base times height.
You're
Base
not
times,
adding.
no, that's it for area.
144.
Right. 144 meters squared. Okay. Now, what's with a circle, I'll do that in a different color here. A circle touches the square on the sides, so its diameter is the same as is also 12. The diameter is also 12, which makes its radius half of that, which is
6.
yeah. So a couple formulas here. The area of a parallelogram, which is what a square is base times height. And the radius is half the diameter, or you can think of the diameter as 2 times the radius. Okay.
Okay.
Now I'm gonna give this to you because we need it. The area of a circle is pi times the radius squared, pi r squared.
So pi. So I need to multiply it by pi and then square it.
So well, you actually first square. So if the radius is 6 meters, you're gonna square 6, and that comes from order operations from this right here, where you do the exponent before you multiply.
Oh, okay.
So what is 6 squared?
36.
36. So here's your answer: 36 pi meters squared, and this is exact.
Wait, do you not multiply it by pi when you're putting it in your answer?
This is exact. So to answer your question, there's two answers. There's the exact answer, which is what this is. And then there's the approximation, which is if you're allowed to use a calculator or have to use 3.14 for pi.
Oh, okay.
So I like the exact because I don't have to use a calculator. You probably are more comfortable with calculator answer at this point in your math trajectory, but this is the preferred answer: 36 pi meters squared.
Okay.
All right. So the progression is like you said, you have a square like that. You have a I don't want to say it. You have a diameter, which is the length of the square. All right. And so let's have you try one more problem like this, and then you find the area from this. So let's see if you can try one. You did real well the other day with that. So again, I'll draw a square. And this time I'll tell you that the perimeter is 24 centimeters. Okay. So a little bit different. Can you tell me the side length if the perimeter is 24 centimeters?
Well, I'd have to do 24 divided by 4, which would give me 6.
6 centimeters, good. So the side length is 6 centimeters. Now, when you draw that circle in there, what is
Mhm.
the diameter of that circle?
6.
It is 6. Okay.
Mm-hmm.
What is the radius?
3.
3 centimeters. And then the area of the circle is pi r squared.
It would be 9 pi.
9 pi, but you need units here, so centimeters squared. So this is your full
9 pi
answer.
centimeters squared.
You
Okay.
have to have the units.
Okay.
You know, if you said if you don't give the units, it could be unclear what you're referring to. Okay,
Okay.
so here's a new problem for you to try on your own.
Mhm.
Let me type it out here. A circle is inscribed inside a square. That's what we've been doing this entire time. The area of the square is 100 inches squared. What is the area of the circle? So what I'd like you to do is to solve this, but I'd recommend drawing a picture and doing just like we did in this previous problem, previous two problems. Find the side length, find the diameter, find the radius,
It would
determine
be
the area.
5 pi squared inches.
Yes. That would, well, sorry, you're very close, very close. I feel like maybe you didn't draw a picture, didn't write out any of the formulas.
Wait, 5 pi square inches?
Again, you're close. Did you draw a square?
Yeah, so you get the square and then
What
it's
is,
10 on each side,
okay, agreed. Now, what is the
and then
diameter?
the diameter is going to be 10, and then you're going to take that into 5, and you're going to multiply, you're going to square 5, which is
That's
going to be
right.
25.
That's right. So that was the missing piece, pi r squared,
Oh, okay.
like that. So yeah, it's 25 pi inches squared.
Mm, okay.
All right, now a related problem, because I mentioned the word inscribed.
Hmm.
There's also the possibility that the circle is circumscribed or goes on the outside. Have you seen this?
Hmm. I
Was
think I've seen
was
that.
that part of today's lesson?
Yes, it was.
Okay, so notice now that the diameter is the diagonal
Hmm.
of the circle.
Okay.
Okay. And that's different than what we've been doing. So it kind of ties into what we did on Saturday. So let's say, let me just redraw this here. Let's say the length of the square, sides of the square, 3 and 3. Do you remember how to find the hypotenuse of a right triangle?
Isn't it a squared plus b squared equals c squared?
It is. Okay, so let's just have so that would be 3 squared plus 3 squared equals c squared. Okay,
So it would be 9 plus 9 equals 18.
okay. And then I think we worked on this last time. How do you take the square root of
You
18?
break it up into prime
Yes,
factors.
yes. So could you try that for us, please?
Okay, it would be 9, 2. It would be 3 on the outside, 2 on the inside.
So
I can't remember how to say it. Sorry.
3 square root 2, 3 square root 2, really
3
good.
square root 2.
Good, okay. So if we go back now and I draw a circle, okay, the
Mm-hmm.
diameter of that circle is the diagonal. This right here is the diagonal, which is the diameter.
Okay.
Okay.
All right. So then I'd have to.
Well, let's just
How would I have?
let me give you a different problem that works out nicer than this.
Okay.
But we'll keep going here. We'll come back to this one.
Okay.
So here's a new square. So let's say the square has a perimeter of 40. Okay. I want you to find the diagonal of that square, please.
Okay. It would be 10, 100, 200. It would be 200, and I do 2 times 100 and 20. No, 2 times 100, 2 times 50, 2, 25, and then 5 times 5, which would give me 10 square root 2.
Okay. Yeah, I heard, I was starting to hear something different, but yeah, the side lengths are 10 and 10, and then you'll learn soon enough why that's 10 root 2. But that's good. So now if we had a circle circumscribed the outside, okay, its diameter is 10 square root 2. So its radius, you have to divide or take half of the diameter. Now that only applies to the number in front. Okay, so
Only the number, not that what do we do with the other number then?
you just leave it square root 2.
But even though it doesn't get, it won't turn into like 1 square root.
It does not. Think of it like this. What is 4 times 5 over 4?
1.
1 times 5. So notice it only applies to the one on the one of them, and it might as well apply to the one that works out.
Okay.
Okay, so that's good. Now the square root's going to go away because our formula for the area of a circle is pi r squared. Okay, so it's 5 square root 2 squared. Now, since you've taken algebra 1 at some point, you are supposed to know how to handle this, to deal with this. Do you recall how to do this?
No, not really.
So here's sort of the long way, is you write 5 square root 2 times 5 square root 2. And you multiply the 5 and the 5. So that's 25. And then you multiply the root 2 and the root 2. That's the square root of 4. What does the square root of 4 become?
2.
2, and 25 times 2 is
50.
50. Okay, so that's one way. The other way, I'm gonna do that over here, 5 square root 2 squared, is you square the 5, and then the square root of 2 you square. So the 5 squared is 25. You can see where that comes from. The square undoes the square root. They undo each other. So you're just left with 2. So 25 times 2 is
50.
50. So your choice, you get more choices the more math you do. But your answer here for the area of the circle is 50 times pi.
Okay, that kind of makes sense.
Okay. All right, now here's where we left off in the previous problem. We can try this one now. I'm just going to grab this line here. We'll do another one here. So where we left off is that the diameter of the circle was 3 square root 2. So the radius is 3 square root 2 divided by 2,
which would be 1.52.
Yeah, and it's almost better to write it as a fraction still. I mean, you can do the 1.5 square root 2, but I would encourage you to use the fractions or do the decimal. Now, the area of a circle is pi r squared. Pi, and then we'll use the decimal here, 1.5 square root of 2 squared. So a couple of options, right? You got to square the first number. And that's why I like leaving it as a fraction. Squaring a fraction is easier than squaring a decimal.
Because then I could just turn it into, it would be 6 over 6.
You're squaring, so multiplying it by itself. 3 times 3 is 9. 2 times 2 on the bottom is 4. Then the square root of 2 squared, that undoes it. So it becomes just 2.
Be 2 and be 18 over 4 still, or would we change the 4 also?
Well, you should reduce this fraction. You should never leave it like this.
Okay, I'd change it to 9 over 2 then.
9/2 times pi. So there's a preference. There's a preference to put the number before the pi.
Okay.
That's
So
just,
put number first, then pi.
yes, yes.
Okay.
That's your
got it.
area. Okay. All right. So here's a new problem for you to try. So this is a square inside a circle. Let's say the square has a side length of 2
Mhm.
inches.
Mhm.
I want you to give me the area of the circle as your final answer, please.
Okay. So first, I need to half it. 2 of 2. I do 4 and 4, and then I do 2. 2 and okay, and then that's that. It would be plus 8 and then 8, and I do 2, 4 divided by 2, 2, and then that'd be 2 on the outside, and then 2 on the inside, and then what do I have to do? I have to half that to give me 1/2. I take that 1/2, and I'd have to square it. That squared would still be 1, and it'd be 2, so it would just end up being area square is 2 pi.
So your final answer is 2 pi. Like
Mm-hmm.
if you could think of the worst punishment in the world and this was wrong, you're very confident in this answer. Is that right?
Yes, I'm
Okay.
confident.
All right. So yeah, so the sides are 2,
Mm-hmm.
and that makes the hypotenuse 2√2. There's a
Mm-hmm.
shortcut for that. And so your radius is the square root of 2 because that 2 in front gets cut out from the diameter.
Mm-hmm.
And then pi r squared is 2
And then the
pi.
square
Good.
cancel it out.
Good. Now the only thing missing is units, inches squared. So they really emphasize
Mm-hmm.
units in this problem. Yeah, that's just the way it goes. There's not there's not a shortcut for that. Now, sometimes what they do is they kind of rotate the square like this. I'm not sure if you saw that in
Yeah,
class.
I've seen that. That
Okay.
is something I actually got caught up on.
Okay, so again, it depends on like what they're giving you. Now this time I'm going to tell you that the radius of the circle is 12 centimeters.
Mm-hmm.
Okay, and this is where we're going to work backwards. This is a more difficult problem. So the radius of the circle is this right here,
Mm-hmm.
and if I draw another radius, it's a diameter. Would you agree with that?
Yes.
But what is it in terms of the triangle?
It's hypotenuse.
Yeah, so if I redraw the triangle, kind of without some of the distraction there, and I say that this is 24, okay,
Mm-hmm.
we know that the two sides are the same
Yeah.
because it's a square. So it's s squared plus s squared equals 24 squared. So I chose a number that's too large. So let me just back off this. Let's go 6 centimeters just so it's more manageable here. Sorry
All
about that. Okay, 12 squared. Okay, so this is 2s squared equals 144.
Mm-hmm.
And you divide both sides by 2. So now you're down to s squared equals 72. What do we do in this case? How do we solve for
We
s?
find the square root as 72.
Yes, so will you do that for me, please?
And so it'll be S and then 72. Here, let me put that in my calculator.
I want an exact answer, no decimals.
Oh, you like with the pi and stuff?
Nope, just breaking it apart. 2 and 36,
Oh,
2 and 18.
oh,
Yeah,
okay.
I want you to keep working
Oh,
through that.
sorry. Okay, so 2 and 36, and that'd be 2 and then 18. So that'd be 9, and then I would take that, and it'd be 3 to 3, and then I'd take that to the out, and then it'd be 6 square root 2.
That's right. So the side is 6 square root 2. So in terms, it's good to redraw them without all the other things. This is 6 square root 2, 6 square root 2. Now, can you tell me the area of the square now?
36 square root 4.
Okay, that's true, but that's not reduced. Like
Oh wait, no, then I can reduce that 4 into a 2, and I would turn that into a 72.
Yes, very good. Okay, so let's try another problem like this here. Let's say I give you a circle and I tell you that the diameter is 8 inches. Okay, I want you
Okay.
to find the area of the square, and it's
Okay.
just like the
turn
problem
that.
we did, just different numbers. So give that a
Okay, so
try,
I turn
please.
that 8 into a 16, and then subside the same length. I do s plus x squared equals 16, and then I'd have to square root that 16. That would turn into 8, and then 4, 2, and it would just be 4 squared. Area would just be 2. 2
Area is
inches
two
squared.
2 inches squared. All right, sounds pretty good. So that diameter is the diagonal of that triangle there. And
Mm-hmm.
so 8 and then s and s. So just like before, s squared plus s squared is 8 squared. So
Mm-hmm.
2s squared equals 64. S squared equals 32. What
Mm-hmm.
did you get for a side length?
It would, for this side, it would be I had to reduce it.
That's right. Give me your reduced answer.
It would be, so then 32, it would be, oh,
I'm
I'm
not
sorry.
I'm not saying you're wrong. I'm just trying to get you to tell me your intermediate steps.
Uh, wait, so I'm confused now. I'm sorry.
It should be 4 square root 2. We're running out of time, so
Yeah.
I'm just gonna give you the answer. Now, remember how to check that? You square the 4 and then you multiply
And
by
then
the
you
2.
multiply it.
Yes,
Yeah.
so that works. Now to find the area of the square, it's good to rewrite it 4 square root 2, 4 square root 2,
Mm-hmm.
base times height 4 times 4, square root of 2 times square root of 2. So 16 times the square root of 4, which
And then
is,
that would be 2, and that would be 32.
yes. Okay. So again, I'm sorry, real quick. Just be careful with your steps here. So the half-hour lessons are actually 25 minutes. We're going to stop right here.